Module 1D. How loud is loud? Before beginning, consider why would you measure loudness? How would you measure loudness? What are the loudest and the softest sounds you can hear? Rock and rollers used to say, "If it's too loud, you're too old, man." And now, they all suffer hearing loss. So, how loud is loud? Well, that question's a little bit like asking, how far away is far away? In other words, it's relative. Your grandmother may think that you're playing your music too loud, but for you, it's just right. So, how loudly are you playing it? Well, in order to answer that question, we have to have a scale to measure how loud is loud. Let's make the softest sound we can hear the beginning of our scale. What are the softest sounds you can hear? We'll call it the threshold of hearing. Tests have shown that the softest sound the average human can hear is 20 micropascals of sound pressure. That's roughly the sound of a mosquito buzzing about 10 feet away. Oh, and a pascal is the international unit to measure pressure. How loud is a normal conversation? Let's make this another point on our scale. And we find a normal conversation measures around 20,000 micropascals, give or take a couple of 3 pascals. Well, there's louder sounds than normal conversation that we need to measure. For example, how loud would a symphony orchestra be playing triple forte? Well, we can measure that, and we find that it would be 2 million pascals. Okay, how about a really loud sound? How loud would the launch of a space shuttle be? Measuring that, we can find out that that would be 2 billion micropascals. Now that's getting pretty loud. So now if we look at our scale, we have from 20 micropascals up to 2 billion micropascals. To make our scale useful, we need a more convenient way to deal with these large numbers.
Enter the decibel.
The name decibel comes from Alexander Graham Bell, who invented the telephone. They needed to know how much sound was lost traveling over the telephone cables, so they designed the bell. Not a real bell, just a measurement. And they found that a bell was a very big number, so they broke it into tenths. So the prefix deci means 1/10 of a bell. So a decibel is just a mathematical comparison between two values with a logarithmic function applied.
What do you say?
Well, for those who enjoy a little math, here's the formula. Sound pressure level, or SPL, is equal to 20 times the log to the base 10 of power 1 divided by power 2, or power 1 compared to reference power, measured, of course, in decibels. Maybe all this stuff about decibels seems rather confusing. Well, it's not as difficult as you might think. Let's take the first two numbers on our measuring scale, 20 micropascals, and compare that to 20,000 micropascals. Using the above formula, 20 times the log to the base 10 of 20,000 micropascals compared to 20 micropascals, we can see the micropascals cancel out, the 20s cancel out, and we're left with 20 times the log to the base 10 of 1,000. So what's 20 times the log to the base 10 of 1,000? Easy. How many zeros are in 1,000? 3. So 20 times the log to the base 10 of 1,000 is the same as 20 times 3, which is 60. 60 decibels. So the difference between the softest sound we can hear and normal conversation is 60 decibels, 60 dB. And if we make the same comparison between the threshold of hearing, the softest sound we can hear, and our symphony orchestra, we see that that is a 100 dB change. Our space shuttle launch measures out at a whopping 160 dB. That's loud. That's loudness that would cause us great pain and hearing loss. For the purposes of this course, we will define the threshold of pain as 120 decibels. This is the point at which your ears begin to hurt. By the time the sound has reached 150 decibels, you have suffered permanent hearing loss. This then shows a range of human hearing, from the threshold of hearing at 0 dB all the way up to the threshold of pain at 120 decibels is the range of human hearing as far as sound pressure goes. 120 decibels of sound pressure level. Before continuing, consider, can you describe what the term decibel means? Can you state the dynamic range of human hearing? If so, continue on to Chapter 1E, the educated ear.